Your air conditioner is killing you. Not dramatically, not quickly, but every time that compressor kicks on and blasts dry, recycled air into your bedroom, your lungs pay the price. Your sinuses dry out, your throat cracks. Your body fights to hold on to moisture in an artificially arid environment that has nothing to do with the actual desert outside. And when the power grid fails, which it will, right in the middle of a 110-degree heat wave when half your city is running AC at full blast, you're stuck in a suburban oven with walls too thin to block the sun and windows too large to do anything but let more heat in. This is modern desert living. A fragile machine fighting a losing battle against physics, powered by a grid that collapses exactly when you need it most. Now let's go back 400 years. A Pueblo family sleeps soundly inside thick adobe walls while the same murderous sun bakes the desert outside. No compressor hum, no electric bill, no panic when clouds roll in and the temperature hits 110 by noon. The interior stays a comfortable 75 degrees. The air is cool, fresh, breathable. They mastered the desert, not with machines, not with fossil fuels, but with physics, biology, and engineering that puts your thermostat to shame. The ancestors built shelters that functioned as thermal batteries, passive air conditioners, and evaporative coolers, all without a single moving part. These weren't primitive huts, they were high-performance engines designed to work with the desert's natural cycles instead of fighting them. Modern architecture tries to brute force comfort and fails the moment the power cuts. Ancient architecture created comfort that never stopped working. The question isn't how they survived, the question is why we forgot. Walk into any modern desert suburb and you'll see the same architectural fraud repeated 1,000 times. Thin walls, oversized windows, cheap materials, designs copied and pasted from temperate climates where they barely function, now dropped into 110-degree heat where they become death traps the second the AC shuts off. These homes weren't designed for the desert, they were designed for the contractor's bottom line. The walls are too thin to provide meaningful insulation. The windows are too large and poorly positioned, turning entire rooms into greenhouses by 10 a.m. The roofs are dark shingles that absorb solar radiation instead of reflecting it. The orientation ignores the sun's path entirely. Without air conditioning, these structures are uninhabitable from June through September. During the summer of 2020, rolling blackouts across California left thousands of desert residents without cooling during triple-digit heat. Hospitals saw spikes in heat exhaustion and heat stroke. People fled to their cars to run the AC until the gas ran out. The buildings themselves offered zero relief. Modern desert homes are parasites on the power grid. They don't regulate temperature, they outsource the problem to a machine that runs 24/7, burning electricity to fight basic thermodynamics. And that machine fails. Heat waves spike demand, the grid overloads, transformers blow. Entire neighborhoods go dark right when the temperature peaks. Your comfort depends entirely on uninterrupted electricity flowing through a system designed in the 1950s, now pushed beyond capacity every summer by people trying not to die in homes that were never engineered for desert survival. The ancestors faced the same heat, the same sun, the same deadly temperature spikes, but their shelters didn't need backup systems. They didn't fail during emergencies, they worked continuously, passively, using principles that modern engineers are only now rediscovering. Thermal mass, convective cooling, radiant barriers, natural ventilation. The ancestral Puebloans perfected this science 800 years ago. The Apache refined it into lightweight, portable systems. The Tohono O'odham built structures that breathed with the desert instead of fighting it. They understood something we've forgotten. The desert's heat isn't just a problem. It's also the solution. The same environment that hits 110 degrees at 2 p.m. drops to 60 degrees by 4 a.m. That's a 50-degree diurnal swing, a massive amount of thermal energy moving in and out of the environment every single day. Modern homes ignore this cycle. They're sealed boxes trying to maintain 72 degrees through brute force while the outside world swings wildly. Ancient shelters harnessed the cycle. They absorbed the night's cold and released it during the day. They pulled in cool ground-level air and exhausted hot air through convective chimneys. They turned the desert's own physics into a passive cooling system that required zero energy input and never stopped working. That's superior engineering. The walls of a Pueblo home are 2 feet thick, not because the builders lacked precision, not because they didn't know how to make them thinner, because those walls store cold. Adobe, clay, sand, straw, and water dried into bricks, has massive thermal mass. It absorbs heat slowly and releases it slowly. A modern wall with fiberglass tries to block heat transfer. Adobe walls work through a 24-hour thermal cycle. They don't resist the desert, they use it. At night, when temperatures drop to 60 degrees, the thick walls radiate their stored warmth outward into the cold air, slowly. By dawn, the entire wall has cooled to near the ambient temperature. That's the charging phase. The walls are now loaded with cold. When the sun rises and the exterior hits 110, those chilled walls start absorbing heat from outside. But thermal mass delays heat transfer. It takes 8 to 10 hours for heat to penetrate 2 feet of adobe. By the time the day's heat starts reaching the interior surface, the sun's already setting and the exterior's cooling again. The inside never experiences the peak temperature outside. While the desert bakes at 110 degrees, the interior hovers around 75. No compressor, no refrigerant, no electricity, just mass, time, and physics. The National Park Service measured this at Mesa Verde and Chaco Canyon. Interior temperatures stay 20 to 30 degrees cooler than exterior peaks during summer days. Modern passive solar researchers call this diurnal heat capacity. They're trying to incorporate it into green building standards now. The ancestors didn't need a name for it, they just built it. And they refined every detail to maximize the effect. Windows were small and deep set, minimizing direct solar gain during the day while still allowing ventilation. They were positioned to catch the low-angled winter sun for warmth, but avoid the high summer sun that would pour heat inside. In Pueblo complexes like Taos Pueblo, families shared walls between units. This cut the surface area exposed to the sun, reducing heat absorption while increasing the total thermal mass working to stabilize interior temperatures. Flat roofs served double duty. During the day, they provided thermal mass above the living space. At night, families could sleep on the roof, their bodies radiating heat directly into the cold, clear desert sky. Radiant cooling that works because the night sky acts like a heat sink at near 0 Kelvin. Every element worked together: the orientation, the materials, the thickness, the window placement. This was deliberate engineering accumulated over centuries, refined across generations, and transmitted as essential survival knowledge. Modern desert architecture has abandoned all of it. Developers use thin walls because they're cheaper and faster to build. They install massive windows because buyers associate them with luxury. They ignore orientation because it's easier to copy the same floor plan in any direction. Then they compensate by bolting on an oversized HVAC system and calling it progress. The result is a house that becomes unlivable the moment the machine stops. The Pueblo stayed comfortable because the structure itself was the cooling system. The thermal mass was the foundation of the entire design. That's the difference between architecture that works with physics and architecture that fights it. The wickiup doesn't store cold, it sheds heat. The Pueblo is built for permanence: thick walls, thermal mass, a fortress. The Apache wickiup is something else. It's light, mobile, and it breathes. The walls aren't solid barriers. They're loose enough to let air pass through. The structure doesn't fight the wind, it uses it. That's convective cooling built into the design. The dome shape matters. When the sun heats the outer brush and the people inside warm the air, that hot air gets lighter and rises toward the peak. At the top, there's an opening. The hot air escapes. This creates negative pressure inside, a vacuum that pulls cooler air in through the porous walls at ground level. It's called the stack effect. Modern ventilation engineers use the same principle for passive airflow in green buildings. The Apache didn't need engineers. They watched how heat moved and built structures that guided it where they wanted. And it doesn't stop there. The walls were made from branches, brush, tool reeds, or desert grasses, woven loosely. When desert breezes blew, they didn't hit a wall and stop. They filtered through, creating continuous air circulation inside. When you added water, the system became an evaporative cooler. Sprinkling water on the brush walls turned passing breezes into chilled air. As wind moved through the damp material, evaporation pulled heat from the air itself. The same process your body uses when you sweat, except the wickiup sweats for you. Evaporative cooling is devastatingly effective in low humidity environments. It can drop air temperature by 20 degrees as it passes through moistened material. The Tohono O'odham use this in their olaski structures, occasionally dampening the Okatilo rib walls during the worst heat for immediate relief. This wasn't primitive survival. This was thermodynamic manipulation using materials you could gather in an afternoon and assemble in a day. And it worked continuously as long as air moved. No electricity, no maintenance schedules, no refrigerant refills, just an understanding of how heat, air, and water interact, and the intelligence to arrange materials so those interactions created comfort. Many wickiups were also built beneath the shade of a large mesquite or cottonwood tree, or under a ramada, a simple flat roof made of brush supported by posts. This created a primary shade layer that prevented direct sun from ever hitting the shelter itself. The combination is stacked cooling. Shade reduces the heat load, porous walls allow airflow, the dome shape creates convective exhaust, and optional water adds evaporative cooling. 4 passive systems working together without a single moving part. Modern architecture seals you inside a box and uses a compressor to fight the outside environment. The wickiup integrated the outside environment into the cooling system. That's why it never failed. When the grid collapses and your AC dies, you're trapped in a static box with no airflow and no way to shed heat. The wickiup kept working because it wasn't dependent on anything except physics, and physics doesn't have outages. The ancestors built shelters that functioned like lungs, constantly inhaling cool air and exhaling heat. They understood that survival wasn't about blocking the desert, it was about moving with it. Your air conditioner dries out your mucous membranes, recycles stale air loaded with pollutants, and creates the perfect environment for mold spores and volatile organic compounds to concentrate in the space where you sleep. The EPA has a name for this: sick building syndrome. It's the cluster of symptoms, headaches, fatigue, throat irritation, difficulty concentrating, respiratory infections, that appear when people spend time in modern climate-controlled buildings and disappear when they leave. Your cooling system is the delivery mechanism. The process starts with humidity. Air conditioning works by passing warm air over cold evaporator coils. The air cools, but moisture condenses out and drains away. What returns to your room is cold and dry, often dropping indoor humidity below 30%. Your respiratory system didn't evolve for that. The mucous membranes lining your nose and throat need moisture to function. They're your first defense against airborne pathogens, dust, and irritants. When the air's too dry, those membranes crack. Your body's filtration system breaks down. You wake up with a sore throat not because you're sick, but because your environment is hostile to basic biology. Ancestral shelters maintained natural humidity. Adobe walls are hygroscopic. They absorb moisture when humidity is high and release it when humidity drops. This buffering effect keeps indoor air within the range human lungs prefer. Wickiup walls, open to outside air, allowed humidity to move freely through the structure. Neither system stripped moisture from the breathing environment. Modern AC does the opposite. Then there's the air itself. Most residential AC systems recycle 70 to 80% of indoor air. Fresh outdoor air makes up only a fraction of what you're breathing. Every sneeze, every chemical off-gassing from furniture or cleaning products, every particle of dust or pet dander gets pulled into the return vent and pushed back into your lungs. Over time, the concentration builds. Volatile organic compounds from paints, carpets, and pressed wood furniture accumulate. Dust mites thrive in the stagnant environment. If there's any mold in the ductwork, and studies show that more than half of HVAC systems have microbial growth, you're breathing spores with every cycle. The wickiup had continuous fresh air exchange. The Pueblo's small windows and convective design pulled outdoor air through the living space and exhausted it naturally. Neither system trapped you in a closed loop of your own biological waste and household pollutants. Your AC does. and when the system fails, the consequences are immediate. A modern home sealed against the environment becomes a motionless oven with no airflow and no way to expel heat. Temperatures inside can exceed outdoor temperatures within hours as the structure's poor thermal design works in reverse. Ancient shelters never had catastrophic failure modes. The Pueblo's thermal mass continued regulating temperature whether anyone maintained it or not. The wickiup's passive ventilation kept working as long as air existed. Your health depended on physics the ancestors understood intimately. Our health depends on machines that create the problems they claim to solve. The Adobe home your ancestors built 400 years ago still stands. The AC unit you installed 3 years ago is already leaking refrigerant. Ancient desert shelters were made from mud, stone, grass, and wood, materials you could gather within walking distance and shape by hand. When a wall cracked, you patched it with more mud. When brush wore out, you replaced it with fresh branches. Repairs required no supply chain, no specialist technician, no proprietary parts shipped from another continent. The structure degraded slowly and could be maintained indefinitely using the same materials it was built from. Your air conditioner is the opposite. It depends on hydrofluorocarbon refrigerants synthesized in chemical plants, compressor motors manufactured overseas, and electronic control boards that fail without warning. When it breaks, you don't fix it yourself. You call a technician who charges $150 just to show up, then tells you the repair costs more than replacement. So you replace it. Every 10 to 15 years on average. The Pueblo at Taos has been continuously occupied for over 1,000 years. Your HVAC system has a design life of 12, and while it runs, it devours energy. The average central AC system pulls 3,000 to 5,000 watts during operation. In a desert climate where it runs 8 months a year, that's 15,000 kilowatt hours annually, roughly half of total household energy consumption. That electricity comes from a grid powered largely by natural gas and coal. The refrigerants inside the system are greenhouse gases thousands of times more potent than carbon dioxide. When units are improperly disposed of, those refrigerants leak into the atmosphere. You're cooling your house by heating the planet. The ancestors cooled their homes using zero external energy. The thermal mass of Adobe charged passively each night. The convective airflow in a wickiup required only the temperature differential that existed naturally. Evaporative cooling needed only water and wind. These systems had no carbon footprint because they worked with thermodynamics instead of against it. Modern AC is a brute force assault on physics. It uses vast amounts of energy to move heat from inside your house to outside your house, making the outdoor environment even hotter. During peak summer demand, entire neighborhoods run compressors simultaneously, dumping waste heat into the air and driving temperatures even higher in urban heat islands. Then everyone cranks their AC harder to compensate. The cycle collapses the moment the grid fails, and it fails often. The 2021 Texas winter storm knocked out power for millions. The 2020 California rolling blackouts left desert communities without cooling during record heat. The 2011 Southwest blackout cascaded across Arizona, Southern California, and Mexico, cutting power to 5 million people in September when temperatures were still above 100. In every case, modern homes became dangerous within hours. Ancient shelters kept working. The thermal mass didn't stop regulating temperature because the power went out. The convective airflow didn't cease because a transformer blew. The evaporative cooling didn't fail because the grid overloaded. These systems were fail-safe by design because they had no single point of failure. Resilience means you can't be stopped in the first place, not that you can restart after catastrophe. We've traded that permanence for convenience, then called it progress. The ancestors built cooling systems from the desert itself, systems that returned to the desert without leaving scars when they were no longer needed. We build cooling systems from global supply chains and fossil fuel infrastructure, then abandon the toxic carcasses in landfills when they inevitably break. Your AC will fail. The only question is when. The Pueblo won't. Modern architects are finally catching up. They call it green building and sustainable design and present it like innovation. It's not. It's the same thermal mass, passive ventilation and evaporative cooling that kept Pueblo families comfortable 800 years ago, just rebranded with certifications and sold back to you as cutting-edge technology. Trom walls are thick masonry walls placed behind south-facing glass that absorb solar heat during the day and release it at night. The Ancestral Puebloans built this into every structure without needing the French engineer's name attached. Passive solar orientation positions buildings to minimize summer sun exposure while maximizing winter warmth. The ancestors oriented every pueblo, every cliff dwelling, every seasonal shelter according to these principles. Natural ventilation shafts use temperature differentials to create airflow without fans. The wickiup's convective chimney did this using a hole at the top and porous walls at the bottom. Phase change materials store and release thermal energy as they melt and solidify. Adobe's thermal mass operates on the same principle, just slower and without the engineered price tag. Every breakthrough in sustainable architecture is rediscovering what the ancestors already knew. The difference is that modern systems still rely on industrial materials, global supply chains, and specialized labor. The ancestors used mud, stone, and branches gathered from the land they lived on. We've made their methods more complicated and called it improvement. But the core physics haven't changed. Thermal mass still stabilizes temperature. Convection still moves air. Evaporation still absorbs heat. The desert still swings 50 degrees between day and night. The question isn't whether these principles work. It's whether we're willing to design with them instead of against them. Because the alternative is what we have now. Fragile boxes dependent on machines that fail when the heat becomes lethal. The ancestors didn't need backup generators or utility companies or technicians. They built cooling into the structure itself, using materials that never stopped working and never needed replacement. That's mastery. Modern society sees mud walls and brush shelters and calls them primitive. Then builds glass boxes that turn into ovens the second the power cuts out. The ancestors built cooling systems that outlasted empires, survived every heat wave, never pulled a single watt. They knew real technology means working with physics so well, the system can't fail. Your AC will break, the grid will go down. Refrigerant leaks, compressors seize, the pueblo keeps standing. Thermal mass keeps regulating. Physics keeps working. That's the native way. Not primitive survival, superior engineering that modern science still can't match. The desert hasn't changed. Heat hasn't changed. Physics haven't changed. Just our humility. Subscribe, and we'll keep digging up what got buried under all that talk of progress.